Hello everyone, it's May the 4th. May the 4th. Yeah, May the 4th, the Star Wars Day. Anyway, let's do the challenge today. Well, yesterday the black screen it was because of my browser. I set up a block on all the videos and pictures, and that's why I couldn't see anything. But the actual footage was there, so it was no issue, no issue at all. It's just the setting from my side. All right. Anyway, let's get to it. No decreasing array. Okay. Given an array with n integers, your task is to check if it could become non-decreasing by modifying at most one element. I feel like I've done this before. I feel like I've done everything. We define an array as a non-decreasing if, yes, for every I, zero-based, such that, okay, true, you could modify 4 to 1 to get a non-decreasing array. False, you cannot get a non-decreasing array by modifying the most one element. Okay, so the idea is, so if the original array is non-decreasing, then we're done. And the only situation that it can is just one of them is wrong. Like one of them either is small, right? Either small, or one of them is large, right? That's the only situation that we can handle, which means if we go through this array, there shall be only one peak or one valley. If we have one peak or one valley, then we say it is true. If it's if they are, okay, let's specify this even more. If we have two peaks, I shouldn't say two peaks. Yeah, if we have like more than one peak, then that's definitely not good. Or more than one valley, that's also not good. Or we say if it's decreasing, then it's like this one is decreasing. There's no peak, no valley. Well, it actually is. If we set the first value as, because we start at minus 10 to the fifth, so we start at a minus infinity, right? Minus infinity, and there will be a peak, right? So we can handle this situation if we set up the minus infinity, and we can also end with positive infinity, right? So we can start with negative infinity and with positive infinity. So we can cover the edge case with the starting and end value, right? So we can capture a valley at the end, right? And capture a valley at the end, and we can also handle a thing at the start. Okay, so that's that. But how do you define a peak? Well, I think if we do, and then we have something big, and then we have something small, right? When something is small, I mean, we can do the non-decreasing, the stack, right? We can use the stack. And the stack, we try to maintain a increasing, and then we just see how many values are popped out, right? So if it's increasing, we push the value into the stack. And if the next value is bigger, then we push it into the stack. If the next value is smaller, then we pop the value from the stack until we meet a value that is smaller than my current one, right? And then we keep going. If it's possible to have only one, then we shall only pop once, right? If we pop twice, then if we pop twice, okay, let's see if it if we pop twice, say we have this, and if we pop twice, if we pop once and I'll pop another time, that means they do not follow, right? They do not follow the trend going up. Would it be a strange case that even if I pop up twice, yeah, it could be. It could be, right? We have a very good going, and we have a small one, a teeny tiny small one, like 1, 2, 3, 4, 0, right? When 0 coming in, we're gonna pop everybody, right? We pop everybody, and as we pop, and new things will coming in. If the new one is, yeah, if it's 1, 2, 3, 4, 0, 5, 6, 7, 8, like this sequence, it's true, but we will pop everything in the front, and then now we end up with 2 arrays, right? We have one is successful and the other, like how do we reconcile that? Yeah, how do we reconcile that? I mean, we can how do we reconcile that? That is a good question. I mean, I don't know. I mean, we can handle the situation where we have peaks, all right? The peaks are easy to handle. Every time we see something smaller, then we just pop. And if I am a peak, then when I see anything that's bigger than me previously, then I pop the big ones. And I can use that to handle all the peaks. But for the valleys, shouldn't we do it like the other way? Every time we see something that's smaller than me, then I pop. But no, for the valley is I am small. I'm very small. And we want to pop something that's small. Like if I am smaller than the previous, then I get popped. Right? That is to handle valleys. We still go through, right? If I, so to handle peaks is when I, right, when I am bigger, no, when my previous is bigger than me, then I pop the previous. That is to handle peaks. And for valleys will be if I am smaller than the previous, then I pop myself. So it's different. Instead of popping the previous one, it's popping myself. It's the same logic, but just the different things get popped. I mean, it's not getting popped, it's just don't get pushed in. So let's see, if we have this 421, right? A 421 will run the peak. The peak will be popped 3 times. So we know it's a bad. And for valley, we say 4 will be pushed in, and 2, I say I am smaller than 4, so I don't get in. I will count 1, and then that will be counted 2. So if we're treating these are just valleys, then we'll have also 2. So both doesn't work. And for this, for the peak, we'll have 4, and that's it. We have 1. And for as long as we have 1, then it's good. Yeah, so that means one of the path functions. And I was just thinking about the valleys, it works. Like if I don't get pushed in, I will go out and everybody, yes, I think this is the solution. Right? So we have to run it 2 times instead of just once. So it's going to be an effort for a 2 time. All right, let's take a look at the, okay, again, we're gonna select all of these. We can actually do this. Yep. So we're gonna say a stack, gonna be this, and we say check for peaks. Well, it's gonna be math.inf, and then we say negative, and we're gonna go to here, say import math, right? One more line, and then we're gonna do check for peaks, right? And we say for actually, we don't even need to use a stack because all we need to know is the number. So we just say pre-max, previous, yeah, just pre. Right? We just need to use a pre. So we just need to go up here. We say CE, say pre equals minus math.inf, right? And then we here just say for and also we need a little bit more. Let's go up. So it's going to be pre and count peak, right? Count peak. So we go here, count peak count, p count. Yeah, p count and v count, pc. So we're gonna go here. That's gonna be 0, right? And then go down. Actually, we're gonna go up. Use O. Yeah, need 4. Any nums. If n is oh, we do need to use a stack because we're gonna keep popping it out. Yeah, we have to use a stack. We have to use it. But when we count, yeah, when we count peaks, we have. Let me see whether we really need to use a stack, like a peak. We pop it out, and then right. So I pop this. I just use myself as the current. Nah, how about the value? The value is just if I'm smaller, then I don't count it. That's it. But if it's more than 1, then we don't have to worry about it, right? Because we only need to return a Boolean value. So if we have more than 1, yeah. So if we have more than 1, then we don't have to worry about it. Okay. Hold on. We're going to do, so we're gonna go here and let's delete it and redo it. So we still need a stack, and the stack can be minus math.inf. Okay, and then I'm gonna say if n is larger or equal to stack minus 1, then stack.append n, right? And else, then we say, which means n is smaller, right? Then we're gonna check to see. Yeah, we do need a number, so we're gonna go. We do need to count for 0, right? And then we go to here, else, if x is aleph, I'm still not very proficient. Elif count is equal to 0, right? Then we say count equal to 0. Then we say stack.pop, stack.append, and we also say count plus equal to 0, plus equal to 1. Else, so we need to pop and then count, and then we just break it. Right? We break it, and hold on. No, I don't like it. I want to do the count first. Which means let's go up. I do think this has to be else. Alright, else. We do else. And then we don't need this. Else we say stack.pop. No, else we say count. Yeah. We say count plus equal to 1, and we say if count is equal to, no, larger than 1, right? After we add it larger than 1, then we break. Otherwise we're gonna pop the current and append this. Yeah, so that's for peaks. And after peaks is checked, we're gonna say if count equals 1, we're just gonna immediately return true, because that means only one peak. We're done. If count is larger, then we can try counting the valleys, which means we're gonna go again. So we're gonna say count equals 0 again, and we say pre equals again minus math.inf and for n in nums. We might be able to do it at the same time. Nah, that's fine. So we say if n is smaller, right, than pre. We're going to say count plus equal to 1. And we're also going to check if count is larger than 1, which means we have more than 1 valleys, then we're going to break, right? And else we just say, no, else we basically don't do anything, right? We don't do anything. And else here, if n is larger or equal, then we say pre equals n, right? So we keep updating the pre until n is smaller, then we do the count. And then if the count is larger than 1, then we break. And here, after we break out, we just see when we return directly, count smaller or equal to 1. And we can also do 22 on here. Deserve a comment. Check for valleys. Okay, so we're gonna go here. Copy this code. Come here. Oh, we can do the test cases. Let's do the test cases here first. Then go this. No. All right. Good. Going down, down. We don't need this. Down. This one delete. Down, down. Go to the front. V. Go up. Okay. We're gonna say C. No, we don't like C. Let's try it again. Go here. Nope. 37. Now we can say V. Go up. So okay. Go 1 to the left. It didn't work. Go to the left. Huh. What do you know? Okay. So test case 4, 2, 3. This one shall give us what? 4 to 3 is true, right? And oh nope, just O. 4 to 1. This one gives us false. Okay, and then J. Nums, so we're gonna say this, and this is nums. Go down. Here CE. Then go check. Possibilities. Run it. S is not defined. Of course, S is not defined because there's no S. In here is only nums. Right, we passed these two test cases. So do it again. I think it's 6. Now the V, select, Control C, go here, Control A, submit, see if we pass. We have a wrong answer. Okay. I don't want to look at a wrong answer. I want to just redo it. Okay, so we have wrong answer. I mean, 1, 2, 3. This one should be fine. Right? This is regular test case. Yeah, 1, 2, 3 is fine. Single value. Yeah, single value. Oh, pressed the wrong button. Single value is also good. Okay. I don't think it's gonna be a true that I return false, because I don't know, like this. Yeah, this is fine. I mean, negative number shouldn't matter because negative number is considered already. So I think the only case is, say, if I have a 10 here, a 9 here, right? Kept pressing the wrong button. A 9 here, yeah. If I do 9 here, let's see. Maybe that's the error case. Oh, here we go. Because it didn't, this one didn't get. How? How? I mean, it gets popped, right? Hold on. For nums, if it's larger equal, we push, push, and push, right? Oh, it has to be a while loop. For this one, I don't think, do we need a while loop for this? No, this one I actually don't think we need a while loop, because it's, we actually try like 4 and 4, right? 4 and 4, we don't need a while loop, and then we shall be able to detect. Oh, it's bad as well. Really? Hold on, so this, if n is smaller than pre, n is larger than pre, so we don't do so pre equals n, pre. Now I am smaller than pre, right? And I count plus equal to 1, which is fine. I don't record this, so it's still 6. And next come up, n is smaller than pre. and count plus equal to 1. So I think this is fine. What is not fine probably is this. Yeah, because I only pop a 1. Yep, the problem is with this. It has to be a while loop. It's this no question about it. So, okay, I'm gonna come up here. What do we have? I'm gonna say while. Actually no. While n is smaller than stack minus 1. Alright? Well, n is smaller than that. Then we say stack.pop and count plus equal to 1. We have to do this. And when it's done, so we don't need, I don't think I need this. Don't need this. No. So all of these can be gone. So while n is smaller than the stack, I'm gonna pop the stack, pop until we cannot pop, and then we say stack.append n. Alright? And after we do that, we can count on the count. And do the count. Which means we're gonna say here, if count is larger than 1, then we're gonna break. And we're also going to go back up. So this is not necessary, which means we can go v this, j, e, d, right? So n is smaller, then it's going to pop. If n is not, then append. And when we get out, we're going to check if count is equal to 1. That's actually if count is not equal to 1. So we're going to go 18 as well. That one is not. That one should be smaller equal to 1, right? Count smaller equal to 1, then we directly return it. If not, we check for values. So again, all right, do it one more time. 6G. Actually, we can do it here. We can do here. O. Right? We have just 1, 3, 5, 4, 4, 8, 8, 9, 10. This one shall be false. All right? And then we're going to say V0W. Yank it, O it, P it. And we're going to do here. So this one is going to be going to be 10, 9. That's to 9. And this one is going to be 9 as well. And this one is false as well. Alright. And then we're going to go to the end. A. Alright, and then we're going to do 1, 2, 3, 4. That is going to be true. Alright. 1, 2, 3, 4. What else? I want to test. That's pretty much it. I mean, let's try one more time. So it'll be 1, 2, 5, 3, 4. Oh, that's a good point. What if you have one peak and one valley? Well, the valley will. If we have this, then we have one valley, and we have more valleys, because these are all considered as valleys. If we have a mixed match, which I'm thinking about like this, right? 1, 2, 3, 4, 6. That shall be a false as well. Oh, I have error on 0, 1, 2. It shall be a false. How? 1, 3, 5, 4 have to pop 5. Oh, this is actually right. This is actually right. Okay, so we do have to do like this. Yeah, because 1, 3, 5, 4, 4, we can just turn 5 into 3, and it makes sense. But now this one should be good. Okay. All right, now let's try it again. G, and we're gonna go V. This, copy, come in here, paste it. Try to run a test case here. Yeah, and if we go, I think last time we go 9 and 9. All right, 9 and 9. That shall be wrong as well. False. Yep. All right, try this one. Pending. Judging. Yep, this one's correct. So, yeah, it is. We cannot avoid it. I was trying to avoid doing a while loop inside. I mean, it's still ON because each value is getting at most traversed twice in the first check. And the second check is the same. And we have some, time saving mechanism out there. Anyway, so how do we move here? And we say D until the end. Yep, that's good. So we're gonna go to row 8, and then we're gonna add, go up, K's go up, and we're gonna add, we use a stack to check for number of peaks. Is the same method, the same method as in other problems where a non-decreasing array is needed for when a non-decreasing array is to be created from a given array. Think about all the water holding problem. However, the trick in this problem is that in addition to considering, let me just double check that we cannot just consider peaks. We have to consider valley as well. Right? If we say don't consider valley, I think it's going to be wrong. I mean, the peak will be correct, all right? But the valley is going to be wrong. Like this is going to be wrong. I'm going to say false, but it's actually true. Yep, so we do have to consider. So considering peaks, we have to also consider valleys. When a single valley exists, the non-decreasing array method won't be able to detect it. Thus, we run another loop to check the number of valleys we have. This second run does not require a step. We basically do not we should discard any value that is smaller than the previous value. We cannot do this for the peak, like anything that's smaller we discard. We cannot do that. Can we? No. We cannot, because the ones we want to discard is the peak. It's not a value. Okay, so it runs on. Technically O3n, right? O3n. On. And check the results here. Meh. 188 milliseconds with 40% ranking. I feel like the solution probably can combine these two together. I don't know, maybe. All right, so I think it has a solution. It does not have solution. It's fine. There's always solution. I do not lose sleep over that because people are very good at sharing their answers. Oh, it's a very low passing rate. I don't think I've done that before. Oh, I did! Oh, wow! I think this is part of the... Isn't this part of the... I think... Did I already start doing LeetCode back then? I don't know. What's the accepted answer? Check even odd. Ooh. Okay, if check whether I is odd. No, it's not even odd. Check whether this is the odd one. Oh, I basically just run through to check if I is 0, num I is the previous one. If I is 0, or nums I minus 1 smaller than nums j. Oh, this is to check the peak. We have a peak here. Num I is, and then I set num I equals nums j. Nums I equals nums j because I is the peak. So I reduce the peak to j, then we keep going. But we count numbers of change. Else, well, the j is the odd one out. So we check I, j, and j plus 1. Yes. If j is the last one, or I is smaller than yes, then j is the odd one out. So we say j equals I, num change plus 1. Yes. Else, which means I is larger than this, and that's not the odd one, that we have multiple odd ones, right? So that just means, say, I plus I minus 1 is also larger than nums j, right? Which means we have 2 previous that's bigger than this. Then we return false immediately. And after we've done this, with the nums, makes sense. Makes perfect sense. Makes perfect sense. I completely forgot. I mean, this is only 2 months and 2 weeks ago, but I already forgot. I have a new method. I don't even remember if I'm not gonna go back to check the code back then, but this is interesting. I already did it before. Greedy. Is it just the one that I copied from? So I prefer to change, yeah, since a larger I will give you more risks that you get inversion errors. Yeah, that's true. But if you also find I minus 2 is larger than, then you have to change everything. Now else you have to change both. Ah, yeah, that is the, yep. I think, I don't know. Did I check these answers? I mean, I didn't upvote it. Who knows? Maybe I did, maybe I did not. Yeah, two modifications. Without modifying input. Extremely easy to understand. Then there are two possibilities. Either the first in the pair can be modified or the second can be modified. Simply modify both of them and then check for validity of the modified arrays by comparing with the array after sorting. Oh wow. So, it is easier to understand. Okay, but it's very memory intensive. It makes sense. Makes sense. We have to modify one of them, and if this larger than this, we make change, and then we break. We make one change, then we break. Oh, that's true, because we can only make one. Wow, this is actually very good. This is actually very good. Yeah, this is the regular one. Modify. Just count number of modifications. It is a great idea. Yeah, I like it. It's a great idea, but you do have to sort it twice. But it's a good idea. I think these are all the same. Yeah, they're all the same. Lower, rise. Ooh, what is this? P is not equal to -1. Turn false. P equals I. 2 times. Okay. Otherwise, coming out. I don't understand, to be honest. AP. So P is the last one where we have an inversion, all right? Okay. P is the last one we have inversion. So P in -1, P starts with -1. P is 0, which means the inversion is at the very beginning, which is fine. Or P is at the end, which means it's n-2. Yeah, so these three are edge cases. Good. Or, if this doesn't matter, then we check P -1. So we have this shape. If P -1 is smaller than equal to P +1, that means P is the odd one out. That's fine. Or AP smaller than AP. That's P +1 is the valley. Yeah, so this is AP. P is the peak. P +1 is the valley. But what if I have 2? how do you reconcile? Oh, if I have 2, then we return false here already. Oh, wow. Also a good solution. Also a good solution. Huh. Very interesting. Yep. So basically, I think the whole idea is to go through the list and find all the pairs that are mismatched. And when you find a mismatch, I mean, the traditional method is just to count how many times we encounter the mismatch. But actually, if we have 2 mismatches, right, we have 2 occasions of mismatch. No, wait. Oh, yes. If we have 2 accounts of mismatch, then it's going to be not possible, right? We can only have 1 account of mismatch, whether it's a peak, that's a mismatch, or a valley, and that is a mismatch, right? So we only have 1 mismatch. If a 2 mismatch, that's it, done. So we have 1 mismatch. So we go through to check mismatch. If we have only 1 mismatch, then we need to see whether this mismatch happens at a location that we can handle, right? So this is what this means, and this is to handle the situation where the mismatch is consecutive. Yes, this is basically to handle the consecutive mismatch. Like we don't have a peak, but we have a platform, like a higher platform. If it's a higher platform, then we only record it once, because AI will be equal to AI plus 1, even though it's a wrong value. But we can use this to check that the mismatch happens only once. I like this one. I like this one more, actually. I like this one more than the counting method, because the counting method usually requires modification of the input array, or setting up a copy, modification of the input array, or setting up a copy of the input array for modification. Yep. Yeah, I like this one. I'm actually write this one instead of the counting methods. I mean, the counting methods is every time you find a mismatch, you do right there, right? You do it right there to check whether the current is modification, and whether the current mismatch, you're correcting it, right? Every time you do it, you're correcting it, and you check again, right? If I have a high, right? If we have a peak, right? We have a peak, then we say we are going to, it's actually not a peak, because it dropped down, right? We drop down, and we say we want to make, we drop down, so we want to check this and this. If it's good, then we modify. And yeah, if it's not good, then we immediately return. I think that's the solution. If it's not good, right? If it's this, then we check whether it's the odd one. If it's not the odd one, yeah, we already immediately return. But a better one would just be to count how many instances of this reverse, of this inverse happens. If there are separate inverse happens, immediately we can say no, it's no good. Now, if there are only one such case, and it could be a single case of inversion, which we can handle, or it could be a platform type of inversion. If it's a platform type of inversion, then we can check to see whether the peak or the valley happens like only once. Okay, yeah, I do like this one a lot. So we're gonna do this one. Yep, we're gonna do this one. And we're not gonna look at it. Nope, not gonna look at it. Try to do it ourselves. Yeah, it's interesting that after 2 months, right? After 2 months, came back to the same problem, and have, oh no, I need this. Yeah, we can close this one. We don't need this one anymore. Oh, we actually do. I want to submit it. Aye. Hold on. Let me get it up again. I need to submit this. Oh, it opens a new window. All right, let's do this. Solution 2. Courtesy of this. The basic idea is to count the number, and find where the last inverse happens. If there are 2 separate instances, 2 or more, right? Two separate instances of inversion, right? Inversion. We can immediately return. Actually, I think this one should be inversion. Inversion. Right? We can immediately return false. If there is only one inversion, we need to examine whether this inversion happens to a single odd number, a single number, either being a peak or a valley, right? That's it. So let's go. So how do we say? We're gonna say index. Let's say I equals what? If there's rather than this, so I will be pointing to the value that is the large one, right? That is the large one. Okay, so we need an n. Right? n equals I is a large one. So I should be starting with a 0, right? But 0 is not a sentinel. So we need as we go, yeah, I is going to be the large value. But we need I to be a sentinel, so I has to be 9 minus 1. N is len nums, that's fine. And we say for, let's go to index. Peak. I like P. I go back to P as well. for I, n enumerate nums, right? I'm going to say for if I n is, oh no, we cannot do it this way. It has to be I in range n minus 1. So we say if nums I is larger than nums I plus 1. That means it's going to be odd 1. So we say P is equal to I, right? And after we updated P, we're going to say if P is equal to I, how do you know how many times P has changed? How did he do it? Because P is allowed to change once, right? And it would change a second time, then that's when we, I mean, in that case, we just count. Yeah, I'll just do count. So C, which means C is going to be count. And P, it doesn't have to be minus 1. It doesn't really matter. All right, it doesn't really matter. So P is going to be I, right? And then we say count plus equal to 1. And then we say if count is larger than 1, then we return false immediately, right? And after we're done, P will be pointing to the single peak or the single odd things out. And then we're going to check if that is a single odd things out or it's a multiple odd things out. So for one thing, if P is at the beginning, right? It's like beginning, drop down, and then go back up. That's good. So if P is in 0, right? That's fine. Or P is at the back, so n minus 2. This is good. P in these two, or that's good. Or we're gonna say if if P is the single peak, right? Single peak. So it's gonna be nums P minus 1 is smaller or equal to nums P plus 1, right? That means P is the odd one out. Perfect, that's good. Or nums, then P plus 1 is the value, so it has to be P is smaller or equal to nums P plus 2, right? If none of these, then we're going to call it. So when I say here, run it, we have an issue, I have invalid syntax. Sorry, the range, I forgot to put this. Oh, we have a failed test. 0, 1, 2, 3, 4. Oh, that's P doesn't change. Yep, that is when P doesn't change. So I have to do this. Yeah, P doesn't change. Okay, let's go back to his solution. How does he doesn't use count. What did he do without using count? Oh, yeah. Oh, wow. Yeah. Do it here. Ah. Nice. Nice. I mean, it's exactly the same. It's exactly the same, but okay. Okay, I take the fee. Yeah, that's a better. That's a good one. Which means we don't need C. Right? We don't need C. We also don't need this. And then when we do this larger than this, we're going to say if p is not equal to -1, which means we already changed p, and we now want to change again, then we return false, right? And we don't need all these. Oh, nice. Very good, very good. Nope. Try not to use the mouse. Nope. V. It's a very good solution. Yeah, I like this better than it's simple, it's straightforward, it's very good. Submit this. Yep, it's very good. What was the wrong answer that I had? I have stack.pop. It's the same thing that I was doing right now, but I didn't check the value. Yeah, you see the value? I didn't check the value, but I checked the value this time. Did I check the answer for this one? I don't know. 212. Maybe I'll go back to our history to see how I did. You know what? I'm curious. I want to take a look. So we can actually see. Let me say cat. No, just 2020. I think. Oh, I don't think I started. No, I started in August. So this is just, why did I do it? I'm pretty sure it's not a contest. I didn't do any contest. I didn't see anything here. You see? It says starting August. I don't have anything earlier than that. What's the number? 665. No, I don't. Oh, I see 665 here. It's right here. So LeetCode 665. Let's take a look. I don't know why I did this, but here's what I said. It's not straightforward. My straightforward idea is to use stack and pop. It does not work because it's hard to reason with the test case. I mean, it is not hard to reason. If it pop all around, the final result will be. It's just impossible to tell whether this is a good one. It is possible. You just need to check the value. Adjacent. Oh, I came up with this myself. Oh, wow, I did come up with this myself. Wow, that was good. I didn't, 2 months. I mean, I use a different solution for this. Interesting to think. It's a completely different solutions, but I still think this is the best one. All right, that's it for today. I'll see you guys tomorrow. Adios.